The following research was possible thanks to donations from people like you who value conservation. Your gifts are vital because Arizona Game & Fish gets 0 tax dollars from the state's general fund.
First summer we moved here, we put up hummingbird feeders, and then the next morning we'd go out and look and some would be dry, and we'd be like, man, I swear we filled that up last night.
The culprits have been caught on camera, draining hummingbird feeders in Tucson, Arizona.
We're in the Catalina foothills, and there seems to be a lot of bad activity around here.
Nectar-feeding lesser long-nosed bats forage in and around Tucson late each summer. These biologists are trying to capture them by partnering with homeowners to install mist nets near their feeders.
The bats must have been hungry tonight because they were setting up the net, and we got a bat before the first net was hardly set up, and 5 more right after that.
8?
Yeah.
Jeez. Very, very cool.
When they catch a bat, they take its measurements, record its sex, and swab its mouth to collect DNA.
To see them close up, yeah, they're just pretty amazing little creatures and pretty docile, really.
If the bat's big enough, they glue a temporary radio transmitter to its back. It's all part of a research project funded by Game & Fish and led by Tucson bat expert Ted Fleming.
And so I'm trying to figure out what makes the leptonectarous bats that we've been tracking, the nectar-feeding bats, what makes them tick? What are the decisions they're making in their feeding behavior every night?
The lesser long-nosed bat is called lepto for short, an abbreviated version of its scientific name. Each spring, female leptos migrate from Mexico to southern Arizona, where pregnant bats give birth to a single pup. They return to Mexico by the end of October. In 2023, Fleming's research focused on tracking the bat's nightly foraging flights in real time, using a sophisticated Atlas tracking system developed in Israel. But the desert terrain and a limited number of tracking stations made it difficult to follow them throughout the entire study area.
So we've scaled back the scale of our tracking this year, and things have worked beautifully.
In 2024, the goal is to get into the brains of the bats by conducting a series of experiments. First, researchers installed 10 tracking stations at houses in the northern Tucson study area.
5 pairs of 2 that are close together. And so then in terms of the netting, we wanted to make sure we netted at all of the 5 pairs of sites.
They captured and tagged a total of 50 leptos.
The tagging allows us to get some feel for the movement of the bats from one site to another, and then how consistent they are in using the same sites where they were initially tagged.
Each tracking station has 2 hummingbird feeders and a radio receiver to detect the tagged bats. There's also a motion-activated camera.
Then they record a 20-second video clip each time that they're triggered, so we can count the number of times that bats are feeding at one feeder versus feeding at the other feeder.
That's important due to the nature of the experiments.
So we have the 2 feeders at each station, and we change the concentration of sugar water in each of the feeders over multiple nights and see how the bats react to that.
For another experiment, they set up plots of feeders at 3 locations in the study area.
And we have 4 corners set up. Each corner has 4 different hummingbird feeders, so that's a total of 16 feeders per site. And so we wanted to kind of test in different areas of Tucson whether or not they are searching for these new sites. And here we're at Agua Caliente Park in East Tucson. And this is the only of the 3 sites that bats have found this food source.
This year, we've gotten a ton of data from both the tracking detections and so forth, and the visual records from the trail cams.
Probably somewhere between 5 and 10,000 20-second video clips. More bats.
Colleagues at Tel Aviv University will be analyzing all of it.
And Goni Namani is going to be in charge of the analysis. And she has suggested that we're going to need some artificial intelligence algorithms to deal with all the video data that we have.
And I'm going to be closing up the nets because we are done.
For the final phase of the research, they captured and tagged an extra 28 bats.
The first bat hit after about 2 minutes of opening the net, and it's 42 minutes later and we have 11 bats netted, so we're able to get the transmitters out that we wanted to tonight. And that is a record.
But we're now putting special tags on these bats in the hopes of being able to track their migration behavior from Tucson south into Mexico and as far south as we can detect them.
We set up 3 antennas between here and the border.
One in Tucson, one in Green Valley, one in Rio Rico, so that gets you very close to the Mexican border.
Once the bats enter Mexico, an existing commercial tracking system will take over.
So we're using a network, a low-power wide area network that's set up by a company called Sigfox.
The Sigfox network is designed to track merchandise traveling in trucks.
And we realized this is a really cool technology to track animals as well. That's the beauty of the system, that you can transmit with really small receivers and transmitters over really, really long distances.
We're just anxious to see whether the system works. It's never been done before, so we don't know.
Now we do know that the system detected a bat just 5 days after it was tagged, about 500 miles south of Tucson near Los Mochis, Mexico. Before releasing a bat, biologists give it some sugar water to replenish the energy it lost during the tagging process. It's fun to see how Lepto's tongues are adapted to feed on nectar from agave and the blossoms of cacti like saguaro and organ pipe. Ted Fleming has been studying bats since 1966.
Not out of questions by any means, but I'm just out of energy.
He's inspired his team of biologists to continue seeking answers to the many questions that remain.
I think it's really fascinating to get inside the minds of creatures and really understand why they make the decisions that they do.
It's great that we've got so much technology now, and we've got these wonderful people that are incorporating technology and their own love of wildlife, and we're learning a lot.